Good day! In this video, we will show you a simple experiment of isothermal process. An isothermal process is a thermodynamic process in which the temperature of a system remains constant throughout the process. During this process, any heat added to the system is balanced by work done by the system, ensuring that the internal energy does not change. The first example of a simple experiment illustrating the isothermal process is the boiling of water. The materials needed for this experiment are, of course, water, a pot or kettle, a stove or heat source. However, you can also use an electric pot or a kettle. To do this experiment, you just need to fill the pot with enough water. Turn on the electric pot to start the boiling process. And don't close the lid of the pot to ensure that the boiling water can maintain a constant temperature and pressure, allowing for a true isothermal process. Then, leave it until it boils at constant temperature. In this experiment, when water boils, it undergoes a phase change from liquid to gas. During this phase change, the temperature remains constant, demonstrating an isothermal process. The energy added to the system is used to overcome the forces holding the water molecules together in the liquid state, rather than increasing the temperature of the water. Another simple experiment for an isothermal process is the melting of ice. You only need ice cubes and a bowl or glass for this experiment. Place several ice cubes in a clear bowl or glass. Leave the bowl or glass at room temperature and observe the ice cubes melting over time. In this experiment, the temperature of the ice-water mixture remains constant at the freezing or melting point, 0 degrees Celsius or 32 degrees Fahrenheit, as the ice melts. This is an isothermal process because the heat energy added to the system from the surrounding environment is used to change the state of the ice from solid to liquid without changing the temperature. And the last experiment for an isothermal process in this video is the syringe and manometer. The materials needed are a syringe without a needle, a rubber tube, and a pressure reader or manometer. Connect the pressure reader to the nozzle of the syringe with a rubber tube. Ensure the connection is airtight. Then, slowly push the plunger of the syringe to compress the air inside. Do this gradually to keep the temperature constant, because if you just suddenly push the plunger too fast, it will undergo an adiabatic process. By slowly compressing the air in the syringe while monitoring the pressure, you demonstrate an isothermal process where the temperature remains constant. This experiment helps illustrate the relationship between pressure and volume in an isothermal condition. In conclusion, we have explored 3 simple experiments that demonstrate the concept of an isothermal process. By observing the boiling of water, the melting of ice, and the compression of air within a syringe, we can witness firsthand how a system can maintain a constant temperature while undergoing changes. These experiments highlight the key characteristic of an isothermal process: the balance between heat transfer and work done, ensuring that the internal energy of the system remains unchanged. It's important to remember that isothermal processes are not just confined to laboratory settings. They occur naturally and frequently in various everyday situations, often without our immediate awareness. This understanding of isothermal processes is not only fascinating from an academic standpoint, but also has significant practical applications in various fields of engineering and science. And that's all. Thank you.